I finished making it and I realised that there was something I wanted to say. Um, so yeah, I didn't know where to put this, so I don't know where I'll end up putting it. Probably just at the start, play it safe. But one of the things I wanted to point out was sometimes at the start of it, before you even do the simultaneous equation, and people who are staying to the end of the video will hear me say this, but if you get a simultaneous equation that has fractions in it at the start, before you do the simultaneous equations, you will go on to get rid of the fraction. And the way you do that is you multiply the whole line by the number that's on the bottom of the fraction, and it will cancel out. I'll do it over here. Let's say you had 3x plus 2 over 7 y equals 6. If that was one of your lines, before you even start, you just multiply the whole line by 7, and then you do 7 by 3, it's 21. 2 over 7 by 7 when you do it in your calculator, or if you want to realize that the 7's cancel, it would just be 2y, and you still have to multiply that by 7. Then you start doing the simultaneous equation. If there's more than one thing under a like let's say this wasn't 3, it was 3 over 5, you then have to multiply the whole line by 5 as well. And just keep doing that till all the things on the bottom are gone. For the honours leaving cert, I'll get more into that later on, because it's more of a risk. Okay, I mentioned to a few of you I was making these videos, and a few of you asked specifically for these, and I think it is handy because it shows up in all of the exams, all in different forms. Some of you don't need to do all of these. Don't worry if you're looking at them and you don't know what they are. Basically, the way it works is everybody has to know how to do these ones. Then these ones are just for leaving cert, and then this one is just for leaving cert honours, right? That's basically the way it goes. So that's all you need to stay for. If you know, everybody needs to do the first one. Ordinary needs to do the first. Ordinary leaving cert needs to do the first 2. Honours leaving cert needs to do all 3. I mentioned to it a few of you as I was doing these videos, and you seem to think it was going to be like your favorite YouTuber was doing it, like it was going to be shits and giggles. But I'm afraid it's not really. It's just me doing maths, I'm afraid. So I guess we just jump into it though. The first one we're going to do is obviously the one that everybody needs to do, so then people can bounce if they don't want to stay for the rest of it. The most common simultaneous equations you'll see are when there's two lines like this, where they don't have any squares or things being multiplied together or any sort of shenanigans going on. When it's just 2 letters and a number, like there could be normally it would be an x, a y, and a number term. Here they have an a, b, and a number term. It's fine. It's just the same process, just with different letters, so it doesn't really matter. So what we have to do is, before you even start these questions, you need to make sure they're in the same kind of order. So you'll notice the first one is a, b equals number, so we're going to want to change the second one into that before we even start. And the way we do it is we use our algebra and just bring the 2b over the other side of the equals, like we normally would if we had just gotten that line separately as its own question. You know, don't get bogged down to thinking of it as part of the simultaneous. You bring it over. Some people are starting to do this, and I prefer this, where you take away 2b, let's say, from both sides. But either way, you should end up with 5a minus 2b equals 25. And now with that, you can actually start the simultaneous equations, because instead of using the second line now, we kind of ignore that. This is our new second line, and that's our first line is still fine. We'll just take that down. Now the whole thing you're trying to achieve here is to cancel out one of the letters. Now what you have to do is you have to multiply sometimes both of the lines, sometimes only one of the lines, sometimes very rarely you don't have to multiply any of the lines, but you want to make it so that either the A's have the same number and different signs, or the B's have the same number and different signs. So because the B's already have different signs, I'm going to choose that one. You could do it with the A's, but you'd have to turn one of them into a minus and leave one of them as a plus. So it's just easier to do it with the B's. A number that what you need to do is you need to think, what are the multiples of 3? They are like 3, 6, 9, 12, 15. what are the multiples of 2? 2, 4, 6, 8, and you'll notice 6 is in both of them, so you want to turn them both into 6. What would you have to do to a 3 to make it a 6? You have to multiply it by 2, so that would give me a 6 here. And then what would we have to do to a minus 2 to make it a minus 6? You'd have to multiply it by 3. And that's what we're going to do. So we're really going to rewrite these lines. Now you have to multiply the entirety of the line by the number, or else it just doesn't work. The maths, you've like broken maths, so we can't do it. So you get like this, and then same down here. I'm hoping I'm not making any mistakes when I'm making these, because I don't want to go back and look at them and listen to my own voice for so long. So if I have made a mistake, I guess in the other videos or this one, let me know. But yeah, I just don't want to have to listen to like an hour of my own voice really to figure it out. But I also don't want you guys learning the wrong thing if I've made a mistake. So by all means, if anyone spotted any mistakes, just let me know, and I'll see if, even if you think it might be a mistake and you're not sure, just let me know and I'll have a look. I really should, but you know. But then at this point, what you can do is do the bit where you draw a line, and now what you have to do is like add all of these things. So you have to add the A's together and put the answer down here. Then we're going to add the B's together and put the answer down here. There'll be an equals here. Then we're going to add these fellas together and put the answer down here. So what we're going to do is we're going to say 8 and 15 is 23A. 6B, take away 6B, because they're the same thing but with the wrong signs, or different signs I should say. They cancel, and you could write plus 0B, you could write plus 0. You can just leave it blank. Some people write plus 0 and then they make like mistakes with that somehow, where they'll write, oh well then it's, some people think, oh you can write plus B then because there's nothing here, because 6 and minus 6 leaves nothing. But that's not, that doesn't mean no B's left at all. That means one B in the maths world, so we're not going to even write that. In here we would get 69. Then you'll notice it's just algebra with like an equation, as in something with an equals, a single number or a single letter, and just numbers then. So it's just normal algebra. You do whatever you'd normally do to get the letter on its own. Divide both sides by the number in front of the letter. So you divide both sides by 23, and you'll notice that you end up with just A equals 3. So that's one of the two letters that we found. Now what we could do is, what you could hypothetically do is do the whole thing again, but this time cancel out the A's. But that would take, not that it would take too long, it's just there's a quicker way of doing it. It's, you know, it's fine. So what you're going to do is you're going to take either of the two lines you started with, or the two lines here, or even two of these lines. It does not matter, as long as you pick a line that has A and one other letter in it. And I know that seems redundant here because there is only one other letter in this question, but I just want to use that terminology for all of them going forward. You always want to sub it back into an equation that has this letter and one other, so we're going to sub it into any equation that has A and B. I'm just going to pick this one just to show you that like it literally does not matter. So what I'm going to do is, what color should I have? So what I'm going to do is I'm going to take this guy over here, and I'm going to, everywhere I see an A, just replace it with 3, because that's what we said. We said A is the same as 3. Then you write it like this. 5 times 3 is 15, minus 2b equals 25, and again it's just algebra. Whatever way you'd move the 15 across in equals, or minus 15 for both sides, you'd end up with this. And then obviously that's just 10, and then you divide both sides by the number that's stuck on the front. So you divide both sides by minus 2. I know that upsets people. Some people just don't like doing the minus thing, but whatever's in front of the letter, we want to get rid of it. And then it's B is equal to minus 5. I think that's the answer. I didn't look at the answers before this, so is it the answer you'd get? Yeah, no, it looks like the answer. Now what sometimes they like you to do is write it like this, because it is like a point on a graph. Because effectively what you're doing whenever you're doing simultaneous equations is you're finding out where the two graphs intersect. You're finding out where the two lines would meet on a diagram. And sometimes in the exams that's how they'll ask it. Instead of saying like here, this was an actual question from this was a junior cert question, I think. Might have been ordinary leaving cert maybe, but the idea is that in the question they just said, here's some equations, solve them. Sometimes it might be in paper 2, it'll say here's two graphs, where do they intersect? where their point of intersection, whatever, then you have to realize that this is really what they're asking you, and then do this question anyway. And I know it's kind of, it can be kind of daunting to just be kind of assuming that that's what they're asking, but if they ask for the point of intersection, like generally it's like I'd say 99.9 times out of 100 it's going to be do this, right? So that's how you do that first one. Yeah, so anything else I wanted to say on that? I don't think so. Just as I said, make sure they're kind of arranged in the right way. In junior cert they'll show up where they'll just say here's a simultaneous equation, solve it. In leaving cert this will just sprout up in some of the questions. But yeah, I guess for now it's alright. I'm going to move on. I don't think, if I think of anything else that I was supposed to say for that, I'll come back to it. I'm not used to just sitting here talking to myself, basically. It's a very unnerving situation. But this one, this bad boy here is more regularly, it shows up most often in ordinary leaving cert exam. Yeah. The problem is with this one is you notice you can't do the same trick of doing this and then adding the things together, because the things don't match. Like there's no x squared on the top line, there's no y squared on the top line, there's no x on the bottom line, there's no y on the bottom line. There's an x squared and a y squared, sure, but they're not the same thing. So we can't just do what we did before, and we use this other method. Now weirdly this method works for all of them, but it just gets so complicated in the first and the third ones that they kind of come up with other ways of going or getting around it. But like, I've bumped into people, everyone that I do maths with has their own preferences for different questions. So maybe there are people who would just prefer to do this all the time, but it can get messy, and I'll show you an example of that now in a second. But here's a kind of a basic enough one where you have, for those people who can't see it, that is a linear equation and a circle equation. So on a graph, the first one, the y, the x and the number, that's just a straight line. But this guy, and if you haven't done it yet, don't worry about it, but just know that that's a circle. And you'll notice that will hit it twice. As soon as there's a y squared in it, or an x squared, just a squared I guess, there's a risk of it hitting it twice. And you could, instead of getting just like the blue brackets we had in the previous question, we could get 2 points of intersection, here and here. So our answer would be like, instead of just being like 3 and minus 5 or whatever was in the last one, there'd also be a second one that's maybe like 7 and 2. That's all. And generally how that's going to come about is we're going to run into a quadratic probably along the way. Be warned. I also saw other questions where it wasn't a quadratic. You could kind of use the other factorizations, but you can always kind of use the minus b formula nowadays anyway, so I'll get to it when I get to it. But the process is you take the easier of the two, the linear one, the one that doesn't have squares in it, and you're going to write that. I'm going to write that down here. I guess I'll do it like this so we know. You write that here, and then what you do is you rearrange it to get one of the letters on its own. It's always easier to get the letter that has no number attached to it on its own, because let's say you want to get the x on its own, you'd have to divide both sides by 2, but then you're stuck with like this looking kind of thing, and that's just not what we want. If we do it the other way and try to get the y on its own, because it doesn't have a number on it, stuck to it, when we get rid of the 5 and move it to the other side, whatever way you guys do that. Sorry, the junior cert people can go now. I think I made that clear, but just so none of you are giving out to me. This is only for leaving cert now, but as I said, it shows up mostly in ordinary level. But yeah, we've rearranged it so that the y is on its own. Easier than rearranging to get the x on its own, because there's no number attached to it. Then what we do is we take that, so what we're saying is y is the same as 2x minus 5. So anywhere we see y, we could change it with 2x minus 5, and everywhere we see 2x minus 5, we could change it with y. So what I'm going to do is I'm going to take that, and everywhere I see y in the harder equation, I'm going to replace it, like I said we can do, because they're the same thing. Now some people that I've done maths with have kind of said, but Graham, that's not a y, that's a y squared. It's fine. Now you're right that they can't be added together, but really the y is still just being replaced with 2x minus 5. We haven't changed from a y squared we've just said that instead of the y being squared, it's 2x minus 5 is being squared. I know somebody's going to try argue that with me, but I don't know, that's not what this is about. I can't seem to draw that 5. Good. But when you sub it in, then you do out the actual maths. And what does a bracket squared mean? It means you write it out twice, because something squared means, you know, multiply it by itself. And then you get this. Now you'd have to do the brackets out here. You know, some people do the loops like this. Some people split the brackets and write the 2x and then 2x minus 5 and then the minus 5 and then the 2x minus 5 and all that nonsense. I'm just going to kind of tell you, either whichever way you do it, this is what the answer should be when you do it. Other people might want to do it the way of, you know, if you're squaring a bracket, it's the first thing squared, second thing squared, twice their product. You know, if you're that way inclined. I've seen plenty of people mess that up though. That's what I'll warn you about if that's what you're thinking. If you're sitting there thinking, I'll do that, but like, you know, just be careful. Make sure you know what you're doing. Now, because we have x squareds, x's, it's supposed to be a squiggly line, that's supposed to be a straight line, x's and then numbers. We know as soon as you see x squared, x's and numbers, it's a quadratic, right? And a quadratic needs everything to be together. So I'm going to bring the 25 over, or have it minus 25 again, whichever way you do that. X squared and 4x squared. If you forget, don't forget that if there's no number in front of something, there's really a 1. So that would be a 5x squared. When you add those together, this would be minus 20x, because they're, you know, the same sign. If they were different signs, they'd cancel, but not if they're the same sign. This is a plus 25, and it'd be a minus 25 at the end. And then we'd get 5x squared minus 20x equals 0. Now this is kind of the example I was going to talk about as the edge case, but it just so happens I bumped into it. Normally when you do this, there will be a number here, like a plus 7 for example, just in there. And you would just do the minus b formula. Now here, because it's not perfectly that, what you could have done is you could have used the other factorization of taking out what's common. And I'm doing this in blue because I'm going to show you something else now in a second that might be controversial, but this is a way of doing it, where you take out what's common and you would get this. And then how can you multiply two things together and get 0? One of them has to be 0, so you'd investigate both of them being equal to 0. Now, another way you could have done it is just rewritten it out as 5x squared minus 20x equals 0. But just slap in a plus 0 to make it a c. You can do that for this part or this part. You just can't do that for this part. That has to be the x squared nut. Yeah. Otherwise, yeah, you can just, if there's missing a number, you can put in a 0 here. If there's missing an x term, you put in a 0 here. And then you can do the minus b formula. You can actually do minus b plus minus. We do need there to be a squared. It's not that if this is missing you can replace it though. That's the one bit that's required to be there. But yeah, you could use this. And what would happen when you do that is you would get the same answers as over here, because over here you'd divide both sides by 5, you know, and get x equals 5 or 0 when you put that in the calculator. And then this side you'd bring the minus 4 over and become a plus 4. So you get, these are your two answers for x. Now I guarantee you when you do the minus b formula for this, where a is 5, b is minus 20, and c is 0, you would get those same answers. Don't forget for the minus b formula, you do not include the x's, you do include the minuses. And if there is a number, or if there's no number in front of an x squared or an x, the number is 1, right? But the thing is, I'm not going to do out the minus b formula. Just trust me that when you do the minus b formula on your calculator, you'll get the same answers as here and here. You'll do it once with a plus, once with a minus in this position, and you'll get your two answers. But do you remember I said at the start that because it's a curved line, there's a chance of 2 points of intersection? That's what we have here. We know there's a point of intersection when x is 0 on the graph, and one when x is 4. But we also, for each of those, we need to know the height of it. We need to know the y value. We can't just put, say, the, you know, points of intersection occur at 0 and 4. We have to say how high up it is as well. We know where in the graph that they're like at 4, but we don't know where exactly on that 4 it is. So that's what we're going to find out. And the way we do that is we resort back to this guy, the guy that we isolated at the start, because we now know that y is equal to whatever 2 times x minus 5 is. So for the first guy, we can say y would be equal to 2 times 0 plus minus 5. When you put that in your calculator, you get minus 5. And for the second guy, you can say y is equal to 2 times 4 minus 5. All I'm doing is taking our two answers and subbing them in for x one at a time. When you do that, you get 3, I think. And then your 2 points of intersection, because you want to write it like, you know, points on a graph, like this. X always has to come first, though. So this one had 0 in place of x, so it's 0. And then for the y value, we got minus 5. So that's what goes in here. And here, for the same reasons, this is going to be a 4 and a 3. I think I've done those numbers right. Again, you can always, if you find a mistake, you know, let me know. If you were to use the GeoGebra app that I always use, if you put these two into it properly, they should intersect at these 2 points, because that's, again, all we're doing with simultaneous equations. We're finding the point of intersection. Now, there was an edge case scenario I was going to talk about. Yeah, down here, if you remember, I said at the start, try to get the one that doesn't have a number stuck to it first on its own. But there are certain situations where that just won't go down. Now, I think they'll very often resort or leave this just to honors in leaving cert, but we're just, you know, just to make sure, we're gonna just I'm just gonna show you how to do it either way, regardless of what you're doing. You still take this guy because it has no squares in it, and you isolate one of the letters, and all that happens is it's just kind of gross. Well, I like it, but you know, let's say you want to get the x on its own. You would then say that's 2x is equal to 1 minus 3y, and then divide both sides by 2, and you'd end up with either this or this. It depends on which way around you prefer it. For me, it depends on the scenario. I actually prefer the first one, and I'll show you why now in a second. But the second one is allowed. You know, you're just dividing the whole line by 2. I just was like cheeky with it, but it's fine. And then what you do is you sub that in. It's the same process, exact same process. It's just here you'll notice when you do it, if we sub it into the first line, if we see an x, we put 1 minus 3y over 2. It just looks bad momentarily. Again, don't forget the squared, don't forget the y's. A big problem people have when they do this is they get so focused on figuring out like what this is and what this is, they just forget about this. They stop writing it. And I understand that you're using so much brain power trying to figure this out that it just kind of doesn't register that there's more stuff at the end. Just remember, try your hardest, I guess. Squared means we write it out twice, so that's what I'm going to do. Yeah, now here we're multiplying this thing by a y. But the trick is, if you remember, anything can be turned into a fraction by slapping it over 1. So really, that you can just say that's y over 1. You're not actually doing anything wrong. It might look unusual because you're kind of thinking, why would you put it over 1? But the reason is because then if you're multiplying fractions, either like these two or these two, when you're multiplying fractions, it's top by top, bottom by bottom. For the love of God, do not use the arrows. So then the top of this fraction would look like whatever those two things multiplied together would be over this. Here it would look like this. You know, I'm just setting up multiplying the top by top, then the bottom by the bottom. Now there might be some redundancies here where you might think, oh, you don't need to write that, you can do that in one line. Whatever, yeah, you like maybe you can do it whatever way you feel like doing it. I'm just trying to make sure that it's as clear as I can make it. Well, I'm just talking to myself. I was going to write 1y, but again, it's fine to just write it as y. I know people like to do it as 1y, but I always like you to know that that's not what they'll do in the actual exams. So it's good practice just to see it. Now that's all I've done. Now before I do anything else, like the only next thing you could do is really put those two minus 3y's together and make it minus 6y, which is fine. But before I do that, no, I'll do it, but I'm just going to be cheeky about it and just get rid of them and make it a minus 6y. I know you can't do that on your page. I'm sorry, I just don't have to write it all out again. I'm doing a lot of stuff. I'm trying to make these as short as possible, but like it just doesn't, it just doesn't work out. But we want to get rid of the fractions. So what we do is, people have different ways of doing it. Some people find the lowest common multiple of all the denominators, or any common multiple, it doesn't have to be the smallest, and multiply the whole line by it and cancel out the things. What I like to do is, because the denominators are 4 and 2, I'm just going to multiply every element of this by 4 and 2. So that first fraction I'm going to multiply by 4 and 2. This fraction I'm going to multiply by 4 and 2. This 2y squared I'm going to multiply by 4 and 2. And then obviously also the last guy. And the reason I'm doing that is when you're multiplying by 2 here and dividing by 2 here, they cancel. Because they're the opposite of each other, we can just immediately get rid of them. And the same here, 4 and 4 cancel here. And our next line would then be 2 being multiplied by everything that was on top of the fraction before we got rid of the denominator. And then here it would be 4 times everything on top of the fraction before we got rid of the denominator. There we go. And now this guy, we still have to actually do all the multiplying. There's no cancelling here, so we just have to actually... That's a 2. That's a 2. We just have to live with it. One of you gave out to me the other day for my 2s. What was that? I don't remember. Some irrelevant fifth year, I suppose. But then, when you multiply it all out, you get 2 minus 12y plus 18y squared plus 4y minus 12y squared. Now, when you're multiplying three things, multiply the two things together first and take the answer and multiply it by this guy. Now, with numbers, that's not too bad. With letters, for the love of God, do it out line by line. Like, don't try multiply all 3 brackets in one line. Multiply 2 together, get the answer in your next line, just write it out, still to be multiplied by the third, and then do that again in the next line. Here, because it's just numbers, we know 4 times 2 will be 8, so it's really just 8 by 2y squared, so 16y squared. And then here it would be 32. And again, you'll notice we have y squareds, y's, and numbers. So what you should have to do is, it's a quadratic, so you bring all the stuff together, bring the 32 across. What would you get there? 22y squared minus 8y. It'd be a plus 2. When you bring the 32 over, it'd become a minus. And then there's an equals 0, because with an equals you always have to have an equals, but there's nothing there, so you write 0. Don't just be like, oh, I don't need the equals. You do. Don't do that to me. I don't know if I remember these numbers. Maybe I messed something up along the way. But this is the process you go through regardless. Yeah, I'm kind of torn whether to finish it or not, because just for time constraints, because it's the same process now. All that's different is that we have to sub in a fraction and deal with that here, but then after that, from here down is basically like in the other question, because there's no fractions. It's just you do a quadratic now, or the minus b, because you can't take out what's common here like we did in the last one. This is more normally what you'd get. Keep in mind though, if you do the fractions or the minus b, those will be your answers for what y are. In my last one I got 2 values for x because the quadratic had x's in it. In this one the quadratic has y's in it. So even if you do the minus b, your 2 answers will be y equals. If you're doing it the brackets way, what you go, or even the minus b way, in the same way we multiplied lines earlier, we can actually also divide this whole line by a number. So for example, I could divide this whole line by 2, get 11y squared. That 8y just doesn't seem familiar, but hang on, maybe. You divide the whole line by 2. Yeah, okay, yeah. And do, you could do this one instead. This one's easier to do. Apparently I'm just doing this out. I was deliberating. You could do the minus b. As soon as you've got quadratic equals 0, you can just use the minus b. Or you could do the brackets like so. Maybe. And again, 2 things being multiplied to give you 0. That you put them both equal to 0 now. When you do your algebra, you get y is equal to 15 over 11, y is equal to minus 1. They look weird, but the fact that this just worked out kind of nice, I'm assuming it's right. I just don't remember. But yeah, now because we have two y values, and I can't stress that enough, when you're doing the minus b formula, everyone assumes it's x equals, but it's only x equals in the log tables because the quadratic in the log tables has x's in it. Whatever letter's in the quadratic, if you do the minus b formula, that's the letter you get as an answer. But whatever letter you get, you take it and you sub it back into this guy, if you recall, because it's x equals, and then you'd say x is going to be equal to 1 minus 3 by 15 over 11 over 2. And what is that? That's going to be 45, 34 over 11. 34 over, I don't know, 34 over 22 maybe. 17 over 11. And then you do the same for the other guy, which would be a lot easier. I say that, what's that? 2, 2, 2, 4, 2, 2, 2. So then your 2 points of intersection would be 17 over 11, 15 over 11, and 2 and minus 1. Because don't forget, the x always has to come first in those. That's the entirety of that question done. I wasn't really planning on doing it. I've killed more time, I know. I'm sorry. But that's again just the process, right? Now, what I'll do is I'll run on to the Leaving Cert. This is only Leaving Cert Honours now. At this point, if you're anything else, you can bug out. It's fine. You can chill if you want. You can stay if you want. Listen to me talk, I suppose. But in Leaving Cert Honours, these are the ones that will show up as well. And they can show up on their own, or they can show up as part of questions. And I will kind of go into that now in a minute. But the idea is, you could use the way we've just used there for the x squareds. But they kind of revert back to the junior cert way. The way that I showed at the very start, where there's 2 lines. Again, this is only for honours Leaving Cert at this point. Yeah, but they use the same thing, but this time instead of there being 2 lines with 2 letters, there's 3 lines with 3 letters. So what we do is, what some people like to do is label them A, B, C, for example, just so we have, that's probably going to annoy people that I wrote it at the back. So, alright, at the front, I just know there's at least 3 of you kind of lost the plot of that one. So you could label them A, B, C. Some people like to name 1, 2, 3, but that confuses the issue because of the numbers in it, and then oh, but there's A, B, C in this one as well. Sometimes they're X, Y, Z. You can call them whatever you want. You know, it doesn't matter. You can call them 3 different letters if you wanted to. But the idea is we're going to take 2 of A, B, C, put them together, cancel out a letter to get D, right? And D will have only 2 letters left in it, because let's say we cancel out. Well, I assume here we're going to all cancel out the C's because they all match number-wise. So let's say we get D to have A and B in it, and some numbers, right? Like, you know, whatever, plus whatever equals whatever. And then what we're going to do is we're going to take 2 different ones that didn't give us D, and we're going to use them to get E. And that will also have A and B in it, equals to whatever. And then what we're going to do is we're going to do D and E together like the junior cert version earlier. That's the whole process. And what actually happened in one of the years, the C, for example, I think was missing the Y term, so it looked like that. So what you only had to do was take A and B, put them together to cancel out the B term or Y term. I think it was X, Y, Z when they did it in the thing, but like, you know, the equivalent here would be B. Cancel out that term so that the D line will look similar to the C line. So instead of having to put D and E together, you could just simply put D and C together. So it actually was half as long as it needed to be. Some people didn't spot that because it hadn't really been done before, and they panicked and just did it like as normal, and so that's fine too. But I'm just giving you options. So what I'm going to do is I'm going to put A and B together. But you'll notice in order to cancel out the C's, they need to be the same numbers but different signs. So I'm going to put A and B together and then A and C together, probably just because the smaller numbers, you know, as best you can. And I'm just going to cancel out the C's. So I'm just going to multiply A by -1 each time, if that's all right. We get this. Don't forget, you always have to multiply the last guy as well. And then I said I'd put A and B together, so we'd end up with this. There was one of these that came up in the mock. Now these numbers are huge. Oh, there's something else I wanted to establish. Maybe do I need to elaborate on that for the others at the start? I don't know. I have to fix that if I do. But there was one that showed up in the mocks in 2018, I think, and the numbers were just huge at the end of it. But it's still doable. It's still only just like the same maths like each time. What I was kind of alluding to there that I forgot to mention earlier was, these numbers are gonna do my head in. Was that sometimes what they'll give you is, and I don't know if I have a situation like this mapped out. Sometimes what they do is they give you a simultaneous equation that has fractions in it. So, example, instead of 4 in front of that a, they might have had 1/4 in front of the a. But all you do in those scenarios is you do what we did earlier, where you just keep multiplying it by all the denominators until they're all gone. It can make the numbers huge, sure, but it's a lot easier than having fractions in it. And the one in 2018 I'm talking about, I think all of the numbers were fractions. Maybe all but one were fractions. So what you have to do is multiply each line by whatever let's say it's 1/4 here and 1/3 here. You multiply this line by 4 and by 3 before we even start the simultaneous equations, just to get rid of it. You don't need to do it for these two, just the one that you want to get rid of the denominators for. Then you do whatever you need, whatever denominators you need to get rid of in the middle one, you do to the middle one, and then in the same manner, whatever you need to do to the bottom one, you do get rid of the bottom one. That's what you do. You do not need to do them all, like all 3 lines by 4 and 3, just whatever denominators are in that line. And then you do that like separately and then start the, kind of like how in the first one I rearranged it before we started. Sometimes you need to get rid of the fractions before you start. That's all. Now I'm going to put A and C together, but I'm going to put the new A, like with all the minuses, if that's okay. Oh, I'm going to put that with C. These numbers are bigger than I was kind of anticipating, so I don't have my calculator on me. I might need to figure out what the hotkey for pausing the recording is to figure that out. So 72A plus 18B. What's that going to be? 37, 44, 100 minus 144 maybe? Yeah, maybe. Yeah. But that would be E. Look, if I get the numbers wrong, you guys know what the method is, alright? It's fine. So now what we're going to do is we're going to put, you notice D and E match, so we're going to put them together in a way that we cancel out one of those letters. And I am going to go for, I've done something wrong, have I? I have done something wrong, like a fool. This is 15 minus 3. I'd say there were so many of you so excited that I fucked it up. You were getting ready to type out things to send to me. Oh, but we're going to put them together in a way that either the A's cancel or the B's cancel. You'll notice to get the B's to cancel, all I have to do is multiply the D line by minus 2. Now you could get the A's to cancel by multiplying the first line by minus 3, but like, you know, effort. So I'm going to double the whole D line and double the whole D line and make it a minus. And we would get this. And then we just write out what A or E is. Is this right? Why do these numbers all... This is what they do to you. They make the numbers look weird so that you kind of question yourself. Then you divide both sides by 24, and what do you get? 12? Minus 12. Oh, A is minus 12. Look, again, maybe I fucked up the numbers. It's fine, you get the process. But then, what I said earlier kind of stands when I said in the earlier question that if you get to this scenario, if you get one of the letters, what you do is you want to sub it back into one of the lines that has that letter and one other letter. There is no point subbing that into these because you'll just be left with B's and C's. There's no point subbing it into these or these. What we want to do is sub them into either D or E or even the new version of D. Does not matter as long as there's an A and one other letter in it. I'm going to just pick D, sure, why not? So I get 24, I never see an A, but in minus 12, that's why not. That is why not. Well, no, I suppose it's the best option, isn't it? 72, 24 by 12 is going to be, I'm drawing a blank here, hang on, 242. 288 minus 28, of course it would be. Minus 288 plus 6b, 72. 6b, that's 6b, equals 72 plus 288. 6b is equal to 360, and then you divide out both sides by 6, you get, oh, b is 60. Now that you have a and b, now you sub it into a line that has ab in one other letter. Now you want to sub it into either the a, b, or c, like in this a, b, or c. I'm going to do it into the capital A because just the numbers are smaller. So it's the same process. It's not too bad. Very often with these things, people fuck it up and get, you know, to the stage where they're kind of like, oh, I got minus 37 over 12. That can't be right. It doesn't matter. As long as you have to process down, as long as you've shown them that you're like, look, I did this, this, and this, but like what I was saying, I might have messed up a number somewhere, or a minus or a plus. Does not matter. Because you will get the majority of the marks for showing that you know what you're doing, that it's not that they went, oh, they did everything right, but, you know, 5 multiplied by 3 isn't 20, you know, they're not going to haul you out on that one. So what is this? It would be 3c equals 807 minus 132, I think. 3c is equal to 675. That doesn't sound familiar. Would you divide that by 3 regardless, and you get 225. That does sound familiar, actually. But oh look, you have A, B, and C. That's how you do these, lads. Again, not too bad. But what I'll warn you is, in recent years, they've started... That's the one that I was talking about earlier, where the one was missing, I forgot to say. So what you would do in this scenario is you put the A and B together, cancel out the Y, and then you'll notice that the D that you make from that can just combine with the C. You don't need to make an E at all. What people did was they got drawn into the Z's because it's easy to cancel the Z or the X because of the single 1 in front of the X or the Z. And they didn't think. But obviously it was like the first time they'd seen it. But recently they've started mixing in sequence, or good lord, they've started mixing in simultaneous equations into different things. So these were both during the COVID years, I think. 2 different questions. I know I've grouped them together kind of, but this one is simultaneous equations in complex numbers. And people kind of freaked out, but if you think about it, it's the same idea where you're just going to find out what one of them is. Oh god, sorry. Find out what one of them is, and then sub it into the second one. And what you would do is, now if you haven't done, you know, complex numbers yet, there's no point looking at this. You would look at that first one and you'd say, oh, there's no Z2 in it, so what I can do is divide both sides by I, or multiply both sides by I if you want, to find out what Z1 is. And you do out that division, you know, where you multiply both sides, the top and the bottom, by the conjugate of the bottom, you know, all that good stuff. And you find out what Z1 is, and then you sub that into this guy, and again use algebra just to figure out what Z2 is. So you know, sometimes you just need to be on the ball, kind of understand what's going on. For every letter in it, so let's say there's 2 letters, you need that many equations. There's 2 letters, you need 2 equations. 3 letters, you need 3 equations. You'll notice here, this question came up, and this one rocked me for a minute or two. It says the diagram shows a cuboid with dimensions x, y, and z. Now I don't know if this is the optimal way of doing it, but this is the way that works for me. Simultaneous equations kind of in disguise, because you notice there's 3 faces, so we can make 3 equations, and that works because it's 3 letters. Each of the numbers is the area of the rectangle it's a part of. So 2 root 2 is the area of this. Now how do you get the area of a rectangle? You do length by width. So to get 2 root 2, they must have done the length. Now I don't know, people disagree on which one's the length, which one's the width. It does not matter. That's the Z, right? Because it's the same as that guy. But what we would do is we would say, oh, length by width means x multiplied by z gives you 2 root 2. And you do that for all of them, so then you'd say, oh, x by y gives you 4 root 3. And you'd say y times z gives you 8 root 6. And then what you do is do simultaneous equations, but again, like, remember I said, as long as if there's anything weird to it, you have to do it the middle way, if you get me, that I did earlier, where you sub it in. So what you do, for example, is you'd say, oh, x is equal to, then I'm going to have to be careful that my 2's and my z's looks different, but 2 root 2 divided by z, just, you know, just more from this guy, and then you sub that in to this one, and you'd get, instead of x, then you could say that's 2 root 2 over z multiplied by y is equal to 4 root 3. But then you work to get y on its own. So what you'd say is, oh, y is equal, there's a couple of ways of doing this. You could, instead of dividing by z, multiply on this side, and then instead of multiplying by 2 root 2, divide on this side, so you'd end up getting y is equal to 4 root 3 over 2 root 2 z, and then you take that and sub it into this guy everywhere you see a y, so you'd end up with 4 root 3 over 2 root 2 z, and then this z is just this guy left behind. This z is from where we subbed in, is equal to 8 root 6, and then you just do like your algebra. You multiply both sides by 2 root 2, divide both sides by 4 root 3, z by z is z squared. You end up with 8 root 6 being multiplied by 2 root 2 being divided by 4 root 3. And what does that give you? That gives you maybe 8. And then z squared is equal to 8, so z is equal to square root of 8, which is 2 root 2. Your calculator will tell you that. And that makes sense because it says, well, we won't get into it yet. But then if you sub that back in, again, you sub it into an equation that has z in one other letter. So I'm going to sub it into this guy, because then we know y is equal to, y will just actually be equal to 4 root 3, because the 2 root 2's will cancel. And then we sub it back into this guy as well. So you sub 2 root 2 in for the z there, and you'll get x equal to 1. And if you remember, that's correct. And then it said find the volume. Volume is length by width by height. You'd multiply the length by the width by the height. So they're getting kind of shady with it. Just be on your toes. Sometimes they say when is fx equal to gx or something, and that's technically simultaneous equations too. You just put the two things equal to each other, and then the two equations equal to functions equal to each other, and you know, play ball with that. Yeah, I think that's everything. I think, again, if I've made a mistake, let me know. If I've left something out, let me know that you think should be in here. But otherwise, yeah, I think that's simultaneous equations in like the majority of it anyway. Yeah, alright.